And now, please welcome Dimitri Bellini and Pietro Antonacci.
Thank you. Thank you to all. I'm Dimitri Bellini. I'm the CEO of Quadrata. Someone maybe know me, someone maybe not. And so, a very short presentation of Quadrata. We are an Italian company, also Italian partner of Zabbix and trainer. And we are devoted to open source solution, and we trust in open source solution, in the real open source solution. So today we want to show a very brief story. So it's experience of work using Zabbix in a good company spread all around the world. They have to monitoring 10 data farms spread in the world. This is the main geographic situation of our customer. Our customer is located, the main quarter is located in Italy, but they have to monitoring this farm spread in United States, maybe in Brazil, and some other in the east of Europe. We don't write so much information because they don't allow. But it's only to try to understand some things that Pietro, my colleague, try to explain later. And most of the time, the customer asks what are the best solutions to implement for monitoring server or maybe host or devices. No? In this case, we propose the classic one. We spread Zabbix in three hosts. One for the main server processor, one for database, and this one is physical hardware for best performance, and another one for the front end. And as a proxy host, we suggest to use virtual machine, but with a good database configuration with MySQL, because they have to monitor a lot of hosts for every farm. Now I give the word to my colleague, Pietro Antonacci, that explain what kind of problem you face in this kind of installation, geographical spread installation. The proxy is good, but sometimes they have some problem. So please, thank you.
Thank you, Dimitri. Can you hear me? Yeah. Okay. So, which were the problems on the customer side? Basically, the infrastructure was made of more proxies, not only two, but we are examining the more problematic ones. The problems the customer was complaining were, of course, not monitored data. And after a basic analysis, we can see that we have huge queues and data center processes at almost always 100%. So, after a deeper analysis, we saw that customer was suffering, maybe for a matter of a big distance, network latencies, big network latency, and overall variable network latencies. We had basically root cause, but could only be a matter of network latency. We mean usually a customer when deploys, particularly when deploys a Zabbix infrastructure on his own, there are some common mistakes like, okay, I'm going to tune better my server, my Zabbix server, and I'm going to leave a configuration on proxy side at a basic level without caring about how the monitoring of the proxies increases, and so without fixing the tuning of the proxy configuration. So we tried basically initially to cancel all the noise that could give us problems on on fixing the network latency. And we found out a first problem that was regarding the time synchronization. Basically, the customer had not NTP synchronization between proxy and servers. And as you can see at a link that we put on the slide, we got some nice suggestions about synchronized timings, because this could be bad problems and could cause bad performance on server side on putting the data on database and so on. So this was an initial fix we put on both proxy and servers. After that, we saw that the basic configuration on proxy side was regarding the database too. After a bit of analysis, we saw that the proxy could not efficiently query its database. There were a lot of slow queries and inefficiently I/O on its disks. So, as it's common, customer doesn't want to upgrade hardware, server or proxy, and we have to fix it in other ways, trying to optimize all that we can. What we did was to switch from standard MySQL to Percona engine, and maybe many of you know Percona and this InnoDB optimization. After that, we fine-tuned its configuration, increasing buffering on database side, and trying to maximize I/O, enabling InnoDB file per table configuration. This means that in this way, proxy database was giving one file for each of Zabbix tables, and this let us to maximize a bit the I/O on disks. After these two changes, we finally came to the sender processes, and we were trying to optimize them. So what we were seeing is that if you try to grab Zabbix processes on proxy, of course, you can see that sender processes give you some useful information about how much time is spending on send its batch of data to server. And we were observing that the two most problematic Brazil proxies had different time zones sending their batches of data. Trying to optimize this situation, we found out that data sender frequency was at the minimum level. So proxy was trying to send data each second, basically. And this could be not so good for the proxy, that instead needed almost 7-8 seconds to complete its batch of data. So we try to optimize the situation, increasing the data sender frequency just at the minimum above the time needed for send this batch of data. And after that, our final optimization on proxy configuration side was to lowering a proxy offline buffer, because of course, if network forced the proxy to cannot send their data, we need to not have a long queue of data to send to server when he finally is back again online. So these two changes let us to go from 10 of 1,000 queue on server side to some hundreds, and was not optimal because network was still there. We could not fix on our own, but was a much more better situation. After this, we have some nice fine-tuning you can do when you have a situation like this. What can you do when you have a server and multiple proxies spread around the world. So what you can do is to have multiple time zones. Of course, you have users of different parts of the world accessing the same front end. So what you want is to show data to these users in different time zone based on their origin. And another good suggestion can be to migrate to 3.0. The 3.0 version has a nice improvements regarding the handshake of proxy and the server. Before this 3.0, when active proxies approached the server, basically the server queried the database trying to recognize the proxy. With 3.0, we use the configuration cache to do this job, and this is of course much faster. So migration is much needed for an infrastructure like this. And finally, a point that maybe we would have liked to have, but maybe we have to wait another version, and that was the possibility to send remote commands to agent monitored by a proxy. It could be very useful in infrastructure like this, but maybe we have to wait. And that's it. We just showed you a brief experience about how to manage an infrastructure with remote proxy and to try to optimize the connection between both sides if you have some kind of network latency or trying to avoid this. Thank you. Any question?
Thank you.
Thank you. Just a second, please.
You work in any way with host dependencies on proxies, so you won't get a very loaded trigger list in case of one proxy going down?
Yes.
Maybe I can explain much more. In Italy, this kind of customer, they call us after they have installed everything and have created a lot of mess. Because they say, we know Zabbix, we do everything without you. But they discover after some time, a few months after, that they have created a mess with proxy, with hosts, and so on. So we don't do so much about trigger and optimization for triggers related to host. We don't do so much because they think they are the best customer that know Zabbix. No? Sometimes
they basically asked us to not touch the templates, so those could be.
Sorry.
Do you have some numbers when you migrated from MySQL to Percona database, what performance gains you saw?
Maybe we didn't record the performance increase because we had very little time to operate the changes. But the other thing that avoided us to record some benchmark was because they were lacking basic tuning. So it was a MySQL standard configuration file. What I mean is maybe the gain on I/O on query was not only for the switch to Percona, but also to fine-tuning of configuration file. But I can assure you it was noticeable, of course. They didn't have so fast disks to operate on. So.
Pavel, please, the question on the back. Sorry, just a second.
One more question. According to your experience, what is the optimal number of remote hosts and items to connect to one proxy server which works good in terms of performance and without data delay?
In this case, we see good performance using a single VM as a proxy. Is able to monitoring near 100 of hosts.
100 of hosts?
100. Sorry, 1,000. 1,000 hosts.
And how many items on each
I don't
host?
remember the number, but they use the standard template. Standard Zabbix template to monitoring a Linux machine. Just a little with some modification for update time, and we have removed some items, but is near the same, so have a good performance. The main problem is related to transfer the data from one nation to another nation through the proxy and the Zabbix server.
They had about 500 VPS per proxy. So at a certain point we had also to split that proxy just to have two channels to let two proxy to send their data and trying to optimize that network latency in that way too. We didn't put on slide, but we made that change too.
Okay, that's clear. Thank you.
Maybe some Zabbix guys can help about that. There are better solutions to monitoring geo-spreaded proxy. Maybe we can talk after.
The default number of values per proxy connection of 1,000 values, have you considered changing that? Maybe you can expand on any tests that you might have done on this?
Splitting? I don't understand, sorry.
So by default, Zabbix Proxy sends 1,000 of values per connection, and in case of high latency networks, maybe increasing that could help because you would end up with sending more data per connection.
Yes, I think we talked about with one of the guys of Zabbix team during our tuning, but
they tried to send us a patch maximizing that value, but after applying that, strangely, it was not so much useful. So we had to continue our analysis and exploration. But we tried that hard-coded value, you mean, right? Yeah, we tried that.
The easy way is to split the proxy. Create two proxy that monitoring the half number of machine. It's better. I don't know why.
Thank you.
Thank you.
When you, I guess you're doing remote monitoring of the proxies themselves as well to the Zabbix agent to get the basic data of those proxies. Have you faced the issue that if you have big queues, as you showed in your graphs, that the proxy data themselves is delayed?
Yes, yes, yes. We see a lot of queue. Yes. Yeah. Most of our work is also aside the monitoring of the Zabbix proxy. Most of the time, most customers don't monitoring the proxy, so it's not able to understand if the proxy is healed or not. And using this information, we have tuned the configuration files or the template or the host parameters and so on.
We needed we need about 2 days because their proxies were monitored by server. So having not proxy monitoring themselves, so not having the right internal data was much harder. We had to wait a bit.
So you would consider to actually connect the Zabbix agent monitoring the proxy directly to the server would be okay to get them upfront?
No, using the standard template, Zabbix template for proxy, without agent.
Now what I mean is if the Zabbix agent talks to the Zabbix proxy and the Zabbix proxy passes the data to the Zabbix server, then and the queue is delayed or the transfer is delayed, then I would get the Zabbix proxy data later. So my question would be, would you consider it a okay practice to connect the Zabbix agent directly to the Zabbix server instead of going through the proxy?
Actually, we monitoring the proxy through the proxy, but we don't investigate so much about that.
Okay.
Sorry. Sorry.
Okay.
Thank you. Finish?
Okay, so we don't have any more questions. So thank you very much, Dimitri and Antonacci.
Thank you.